Homework number 3 has 4 problems involved. And the first 3 problems actually work all with each other. So let's start with the first one and get the information we need, move on to the second one, and then the third and the fourth problem. Number 1, here's a series of weekly demand data covering 8 weeks that the Forever Young cosmetic company collected on one of its products and forecast for the corresponding weeks, made by Forecast Model 1, which the cosmetic company is testing. So, using that information that's given, the actual demand and the forecasted demand, compute the mean absolute deviation based on all 8 weeks of data, and then compute the square mean error based on all weeks of data. So we need to know the following information. What's the formula for MAD? How do we figure it out? What's the formula for MSE? And how do we figure that out? Well, knowing that we have our actual demand and our forecasted demand, what we're going to do to find our MAD, which is equal to the sum of the absolute value of the actual minus the forecasted divided by the number of observations or the weeks that we have here, and our N here is 8. So looking at the formula, I'm going to take the demand for week 1, the actual demand, and subtract the forecasted demand. So that's 218 minus 240. And you should get a negative 22. But we want that absolute value. What's the absolute value? It means taking away the sign. So instead of negative 22, it's just going to be 22. For week 2, it's 275 minus 45, which is going to be a positive 30. But again, the absolute value is just 30. For week 3, it's going to be 244 minus 250, or a negative 6, but we want that absolute value again, which is 6. For week 4, 262 minus 255, which is 7, positive 7, but it's actually just 7 for the absolute value. You're going to go through and do each week this way and then add them all up together. And when I look at my absolute values, I got 132, summing each one of those weeks up. And again, we had 8 weeks. So my MAD here is 16.5. Looking at B, the mean squared error, what are we going to do? We're going to take the sum of the actual minus the forecasted in each week that we've squared and divide by, that's an N, folks, N. Remember we said our N was 8, the number of weeks have not changed, but how do we find that sum of A minus F squared? Well, we take each week, starting with week 1, 218 minus 240, get a negative 22, and square it. That's 484. 275 minus 245 for week 2, which is 30, and square it, which is 900. And go on through each week that way, then add up all those weeks together. And I got 3,256. Divided by N, I got 407. Looking at problem 2 here. The Forever Young cosmetic company used Forecast Model 2 to forecast demand for a different product. 8 weeks of actual data and forecast data are shown below. And we want to, again, calculate the MAD, the MSE, but we also want to add in the MFE. So let's start with our MAD, which again we said was the sum of the absolute value of A minus F divided by N. If you notice, our N is still 8 weeks, that has not changed. But the demand here for this product in week 1, the actual demand was 136 with 150 as being the forecasted demand, which is a negative 14 or a 14 if we take the absolute value. The second week was 151 minus 160 that was forecasted, or a negative 9 or a 9. We're going to continue on like this, just like we did with the first problem, and add them all up together, and we end up with 104. I take 104 divided by 8, and I end up with a MAD of 13. B looks at MSE, mean squared error. And again, this is the sum of the actual minus the forecasted squared divided by the number of weeks. Again, the number of weeks is 8 that we're looking at here. And again, we're going to take the first week's actual demand, 136 minus 150, and square that number. For negative 14 squared is 196. Go down through the weeks, add them all up together, and I get 1824. And if I divide that by 8, I get 228. Our mean forecast error is actually the running sum of the forecast error divided by n, and the running sum is actually nothing more than the actual minus the forecasted in each week and summed up, divided by n. Our n of 8 has not changed, but this time we're actually keeping the sign on. So our week 1 actual minus the forecasted is a negative 14, for week 2 negative 9, for week 3 20, for week 4 negative 6. You go through and take the actual minus the forecasted for each week and then sum up those numbers. I got a negative 4, which means that it's a negative 0.5. And what does that mean? A negative means that we are over forecasting, where our forecast numbers are higher than the actual demand numbers. In the third problem, it asks for you to do the MAPE, the mean absolute percentage error. And if we look at it for our first problem, or actually the formula for both, is actually 100 times the actual minus the forecasted divided by the actual. Take that absolute value, multiply it by that 100 again, and divide by n. Our n is still 8. That hasn't changed. But how do you get that actual? Well, if we take a look back at week 1, I'm going to take the absolute value of A minus F, multiply it, divide it by my A, and then multiply by 100. And so for week 1, this is going to be 218 minus 240 divided by 218. Take the absolute value, then multiply by 100. Remember, you have to stay in the same week with all of your numbers. So for this, I got 10.09174. After you get all 8 weeks done, you're going to add up all of these numbers. And I got 53.09475. I divide that by 8. And remember, this is a percent, 6.6368% of errors. So there's over 6.5% of errors going on there with the forecasting. Looking at the MAPE For week 2, remember it's going to be 100 times the actual minus the forecasted divided by the actual's last absolute value divided by n. Our n is 8. Again, if I do that for each week, I'm going to find that I get 67.24599, and I'm going to get 8.4057%. So we want to discuss what's happening, who's doing better. MAPE 1 is MAPE 1 was 6.63%. The MAPE for forecasting method 2 was 8.405%. What's doing better? Percent of errors that we're looking here. Actually, you have a lower percentage of errors in the first forecasting method. If I look and compare my numbers from my MADs, my MAD for 1 was 16.5. My MAD for 2, if you remember, was 13. For mean absolute deviations, who's deviating more? Who's doing a better job with less deviation? Here we have the second one. They have less deviation. It also asked us to compare our MSEs. The MSE for 1 was 407, mean squared errors, and it was 228 for the second one. So who has the lower squared errors? That means when we find the bigger errors actually get multiplied out and made even bigger. So again, the second formula is doing better on mean squared errors, but the first formula, back to the MAPE, had a lower percentage of errors. So we have to take a look at what we're looking at, what we want it to do to see what actually means something is doing better. Looking at the fourth problem, given a monthly demand on a product, compute the 3 months moving average, the 6 and 12 month moving averages, and plot the data. Here is that information. If we take a look at this Excel, again, this is homework number 4 on your, or problem number 4 on your third homework assignment. If we look at this, column A has the original data for the actual demand. Column B is a 3 month moving average, and I found it by taking month 1, 2, and 3 and divided by 3, and then took month 2, 3, and 4 and divided by 3, and then 3, 4, and 5, and so on. If you take a look at the third column, this is a 6 month moving average, and you're looking at months 1, 2, 3, 4, 5, and 6 added together and then divided by 6. Remember, it's just a simple moving average. And then the last column is a 12 month. When we look here, the blue dots are your original data. 3 months is in hot pink. Bright yellow is your 6 months, and your little turquoise with the X's on the line is your 12-month data. What's happening here? Well, if you notice, the original data is sort of, the plots are all over the place. 3 month, it's condensed down a little bit and it's smoothed a little bit. But notice 6 month, the nice curves that it gives. It literally is showing how smooth that information is, and the 12-month data is almost a straight line. Why would we use a 3 month versus a 6 month or a 12-month data? Well, if you're producing for how much you expect you're going to need to sell, etc., if it's something that you can produce evenly and store, you might want to look at the 12 months data so that you have a steady production and you're not varying that. If it's something that has peaks and valleys, seasons, etc., you might want to take a look at that 6 months data that's smoothed out a little bit. If it's something that you need to stay on top of because it varies frequently, that 3-month data might be better help you with your forecasting your demand. So looking at this and actually taking the 3, 6, and 12-month data and simple moving averages and plotting that data shows us what type of information we can get, and it will be used for different reasons.